In today's video, we are looking at parallel lines and perpendicular lines. Now, we say that two lines are parallel algebraically if and only if their slopes are equal. Now, geometrically, we think of two lines being parallel if they never intersect each other, which is equivalent to the algebraic definition that their slopes are equal. They're increasing at the same rate or they're decreasing at the same rate, so they never have a chance to cross over each other. So in this video, we're going to be looking at two lines, and we're trying to determine whether these two lines are parallel, and then we'll look at an example to where we can determine whether two lines are perpendicular. But first, the parallel. We've got two examples here that we can look at. In the directions for the example, we want to determine whether the lines passing through the given points are parallel. So we have two lines. I'm calling these L1 and L2. And L1 passes through the points -1, 4, and 1, 3. Line 2 passes through 2, 6, and -2, 8. Now, we can graph these 2 points and draw a line through them so that we can see that geometrically, if that helps you visually. But we don't need to do that. All that's necessary is to calculate the slope of these two lines, and as long as we know 2 points, then we know the slope. So let's do that. For first line 1, we can find the slope by subtracting the y values and subtracting the x values and dividing the differences. So I will subtract the two y values, 3 minus 4. I'm doing that y2 minus y1, and then I will divide that by the difference in the x values. That would be 1 minus a -1. Be careful with your minus signs when you're subtracting. Remember, 1 minus a -1 becomes plus. All right, so 3 minus 4 is -1. 1 minus a -1 is equivalent to 1 plus 1, which is 2. And so we have -1/2 for the slope of line 1, right? So the slope is negative, so this line would be decreasing. Now we can look at the slope of line 2. The slope is the difference in the y values, 8 minus 6. And we're dividing that by -2 minus 2. 8 minus 6 is 2. -2 minus 2 is -4. If we can reduce that, right, we can reduce 2 over -4 into 1 over -2 or -1/2. So since these slopes are the same, we can conclude that L1 and L2 are parallel. They will never intersect. Okay. Well, what about example 2? For example 2, let's do the same approach, right? Finding the slope of L1 and the slope of L2, and then we want to see if they are the same. For L1, we can again take the slope formula, subtracting the y values, -2 minus 3. And subtracting the x values, 2 minus 2. Now, what do you see here? The x values are the same, so the difference in the x values are going to be 0. We know we cannot divide by 0, so what does that mean about this line? That means it's a vertical line. That means the slope is going to be undefined because 2 minus 2 is 0. We cannot divide by 0, so that means we have an undefined slope. All right, so now is the slope of L1 undefined? If it is, then these two lines are parallel. If they're not the same, then they're not parallel. So let's take a look. And we can just look at these ordered pair and see that the x values are the same, right? So again, we're going to have a vertical line with an undefined slope, but we'll work it out here. Subtracting the y values, 5 minus 4. divided by the difference in the x values, -2 minus -2. 5 minus 4 is 1. -2 minus a -2 is 0. So again, we have an undefined slope. All right, so these two lines, L1 and L2, are both vertical. Which means that L1 and L2 are parallel because two vertical lines are never going to cross each other. All right, so two lines are parallel if and only if their slopes are equal or if both of the slopes are undefined. In these two cases, L1 and L2 are parallel. Now, if I didn't show an example, right, but it's straightforward enough. If you calculate the slopes of the two lines and you do not get the same answer, then that means that the two lines are not parallel. So now looking at perpendicular lines. Geometrically, we say that two lines are perpendicular if they intersect at a right angle. Algebraically, that means that two lines are perpendicular if and only if their slopes are negative reciprocals or opposite reciprocals. Now, a reciprocal is when you flip the fraction, right? If you have A over B, you can flip that to read B over A. That would be the reciprocal. Negative, meaning that you take the opposite sign. So if the original fraction was a positive, you would flip it and make the sign negative. And vice versa. If it's already negative, you would make it positive. All right, so for example, if line 1 were to have the slope m, let's call it m1, and if L1 is perpendicular to L2, then the slope of L2, we could write that as -1 over m1, where m1 is some number, right? And if you like to put specific numbers in there, let's say m1 is 2, right? And if L1 and L2 are perpendicular, then the slope of line 2 would be -1 over 2. Okay, or if m1 is 2/3, right? You would flip that to make it a -3/2 for the slope of L2. All right, let's look at some examples here. Determine whether the lines passing through the given points are perpendicular. Now, we can approach this the exact same way as we did with these parallel lines. And in the previous examples that we worked, right, if we were trying to determine whether the lines are perpendicular, of course, our answer would be no, because we saw that they were parallel. All right, let's look at these 3 examples here for the perpendicular. So we'll again start out by finding the slope of L1 by subtracting the y values, -2 minus 0. We're dividing by the difference in the x values, 1 minus 2. All right, so -2 minus 0 is -2, and 1 minus 2 is -1, which will simplify to be a +2. -2 divided by -1 is a +2. And now the slope of L2 would be the difference of the y values, 4 minus 2. And that's divided by the difference in the x values, -8 minus 4. So 4 minus 2 is 2. And -8 minus 4 is -12, which would simplify to -1 over 6. And so since the slopes are not the same, of course they're not parallel, but they're not negative reciprocals either, right? And if you want to visualize this better, take the slope of L1, and if you take the negative reciprocal of that, you'd make that negative, and you'd flip that around to make it 1/2. And if it's a whole number like this, 2, right, you can think of this as 2 over 1 if you need to, right? Then you flip the 2 over 1 to write as -1/2. Since these are not the same, that means that the lines L1 and L2 are not perpendicular. Okay, so I'll just say no here. All right, these two lines are not perpendicular. All right, so let's move on to example number 2, finding the slopes of L1 and L2. All right, we can subtract the y values, 2 minus 5, and divide by the difference in the x values, -1 minus 3. 2 minus 5 is -3, and -1 minus 3 is -4, which simplifies to 3/4. -3 divided by -4 is a positive 3/4. And the slope of L2 is the difference in the y value. 6 minus 2 is 4. And the difference in the x values, -3 minus 0 will be -3. I'll write that out here. That was, what would say, 4 over -3. All right, so are these two lines perpendicular? Are they negative reciprocals? I'll write that negative in front. By the way, if you have a negative in the denominator, that's the same as writing the negative in front of the fraction. Right, that negative can float around, or you can move that negative to the numerator, or you can just move it outside in front of the fraction. Right, so 4 over -3 can also be thought of as -4/3. All right, so we can look at these two fractions, and we can see that they're just flipped around. All right, the 3 over 4, if you flip that, that becomes 4 over 3, and they have opposite signs. The first slope is a positive, the second slope is a negative. So these are negative reciprocals. So our answer to our question, are these two lines perpendicular? We would say yes, they are perpendicular. All right, and then for example 3, finding the slope of line 1 and line 2, we will subtract the y values, -1 minus 5, and subtract the x values, 3 minus 3. Now we know, since the x values are the same, this is going to give us a vertical line which has an undefined slope because we cannot divide by 0. And then we'll find the slope of L2. 2, all right, subtracting the y values, 2 minus 2 divided by the difference in the x values, 0 minus 4. All right, so what happens here? Now, in this case, the y values are the same. 2 minus 2, that'll give us 0. All right, and 0 in the numerator means the slope is 0. 0 in the denominator means the slope is undefined. And 0 and undefined are negative reciprocals of each other. That's more difficult to see, but we've said that a line with an undefined slope is a vertical line. A line with a slope of 0 is a horizontal line. And a vertical line and a horizontal line are perpendicular, right? Because, right, you can think of the XY axis. Those intersect at right angles. Those two lines are perpendicular. So we would say yes in this case, for example 3. A vertical line and a horizontal line are perpendicular because they will form a right angle, or their slopes are negative reciprocals, meaning that an undefined slope and a slope of 0 can be thought of as negative reciprocals.